So for our activity, for our first activity, so we have to install first the needed software for Arduino. Okay, so to install needed software, so first we have to go to then here you can buy that Proteus. You can click buy now and then download the Proteus, or you can download the demonstration version of Proteus. So if you want to try Proteus first before buying, so you can click download version here, demonstration version here. Okay, so you have to click here, then you can now proceed to downloads. Then after downloading the Proteus, you can install it. Okay, then after installing Proteus, you have to install Arduino. Okay, so Arduino, you have to go to www.arduino.cc/n/main/software, or you can simply search for Arduino software. Okay, then in this website you can download Arduino. Okay, so you have to scroll down, then click Windows installer for Windows 7 and up. Okay, this is for an offline installation, or you can download Windows zip file for non-admin install. So it is a portable. Then Windows up requires Windows 8 or 10. So if you want to install Arduino from Windows app or Windows Store. Okay, so if you're using Mac OS, then you have to download Mac OS X. And then if you're using Linux, we have here installer for Linux. So since that I'm using Microsoft Windows 10, so I have to download this and then install in my computer. Okay, so after downloading, all you have to do is to install, just like other software. All you have to do is to click next, and then just select the default installation. Same also with the Proteus. And after installing Proteus, okay, and Arduino, so second, you have to download the Arduino library here in this website. You can download that here or in any website, since that is an open source library. Okay, so you can download it here. So below you can download the library. Okay, so download library, so you can click this to download the Arduino library. Okay, and after downloading the Arduino library, so you have to show in folder, then right click on this and then extract to Arduino library for Proteus 1. Okay, so these two files, the .idx and .lib, all you have to do is to copy this. Okay, copy and go to drive C. Okay, drive C, then go to program data, then find for Lab Center Electronics, then Proteus 8 Professional, then go to library, and then all you have to do is to paste that 2 file here. Okay, so now we're done adding the Arduino library to our Proteus. Okay, so if you want to add other libraries to Proteus, all you have to do is to download that library and put that here in the Program Data, Lab Center, Electronics, Proteus 8 Professional, and then Library. Then restart the Proteus, and then you can use that library. Okay, so now let's proceed to running or creating a very simple project, our very first example of running Arduino in our Proteus 8 Professional. Okay, so this is how you simulate Arduino using the Proteus. Okay, so let's close this, then let's run Proteus. Okay, so this is now the newly installed Proteus 8 Professional. So all we have to do is to run this application. Okay, and then File, New Project, or you can click New Project here. If you want to open a project, you can click Open Project. Okay, so if you have a legacy design, you can import that. Okay, so we have also examples here. So let's create a new project. Okay, new project. So it's initializing the project wizard. So let's wait for that. Then we have to rename our project. Let's say this is sample 1. Then we have an option here to you can choose new project or you can choose from development board. So let's leave it default. Okay, new project, and then click next. Okay, so I have already that file name, so I have to overwrite that. Then let's create a schematic from selected template, and then choose default, and then click next. Then since that we're not going to create a PCB, we're not going to or let's say we don't need a PCB layout for this project, so let's leave it default that do not create a PCB layout. And then if you want to create a firmware for this project using the Proteus, or let's say using the MPLab, we can select create firmware project. If we're not going to specify where the firmware coming from, so you can select no firmware. Okay, so if you want to develop this project with a firmware coming from a different, or you have to specify the compiler, then you have to create a firmware project. Let's say, for example, we have to create a firmware project. Then you have to select the family of the microcontroller that you have to use. Okay, let's say, for example, we have PIC16. Okay, PIC16 family. Then what specific controller of PIC16? Let's say, for example, PIC16 F84A. F84A. Okay, this one. Okay, PIC16 F84A. Then let's compile that using the MPLab XC8. Okay. or you can use also the built-in compiler of Proteus, or you can use the mplab exe8. So the mplab exe8, so you have to install mplab and then the exe8. So it is a two different file. Okay, then let's select, for example, mplab exe8, then click next, then finish. Okay, so then this is now the working environment of Proteus 8. Okay, so since that we created the firmware, so it opens a tab for a firmware here. So you can code here, then so if we created PCB layout, so it will added PCB layout here. So since that we did not add a PCB layout, so we don't have a PCB layout tab here. Okay, so since that we don't need this source code or the firmware coming from exe8 or coming from the Proteus, let's close this tab. Let's focus on development of the firmware. So since that we selected the PIC16 F84A, so it automatically added to our working area. So let's delete this because we're not going to use PIC16. Okay, we already have the VDD. Let's delete that. Okay, so to add Arduino or to add component, okay, or electronic component in this working area, so you can select this component mode. Okay, this one, the component mode, then select this icon, the letter P for PIC component, okay, or PIC device, then search for that component. Let's say, for example, Arduino. Okay, Arduino. And okay, so we have Arduino here, different types of Arduino. So we have Arduino Mega 2560, Arduino Mega 1280, Arduino Mini, Arduino Nano, Arduino Pro Mini, Arduino Uno. Okay, so I will going to use Arduino Uno for this example. But if you have, if you need more IO, you can select at Mega 2560. So it has 54 IOs. Okay, Arduino Uno has 14 IOs. So let me select Arduino Uno. Okay, then click. Okay, click to add that component here. And okay, so we can rotate this if you want. Rotate clockwise. So all you have to do is to right click. Sorry, we have to right click, okay, on this component and then select rotate. Okay, let's say for example rotate anti-clockwise. Okay, so yan na. So balik natin siya, rotate clockwise. Yan. Then drag, you can drag. Okay, then let's add resistor. Sorry, resistor. Okay, resistor. Click resistor here and then select the subcategory. Let's say we're going to use 0.6 watt metal film. Okay, then let's find for 300 ohms. 300 ohms. or you can select any of these resistor, then edit the value. Okay, so this one, okay, that's 300R resistor. So okay, so and then let's add an LED. Okay, then let's use LED blue, active animated LED model blue. Okay, so animated. So hindi tayo pumili dito because this is self-flashing. Okay, self-flashing. Ibig sabihin, wala kang control sa pag-flash ng LED na to. So dito tayo. Okay? And then okay, and then add that here. Yan. Then layan natin konti. Okay? Or let's rotate this anti-clockwise. So dugtong natin dito. Okay. Ilapit natin dito banda. Okay, then let's right click and then place terminal, and then let's select ground. Okay, ground. Then pipili ka dito ng gusto mong pin na gagamitin, no? Ito yung mga I/O natin. Pag sinabing I/O, you can use this as an input or output, okay, of your project. So you have from 0 to 13. But 0 and 1, yung 0 and 1 na to, usually hindi tayo nagkakabit dito kasi this is the transmitter and the receiver. Okay? So doon tayo magsisimula sa number 1. Kasi itong part na to, pag ginamit mo, minsan parang nawawalan ka ng control. So doon tayo sa number 2. Okay? And click mo lang yung dulo. Click. Pagka-click mo, then dugtong mo dito sa resistor. Click. Then click ulit. Dugtong sa LED. Click ulit. And then dugtong natin sa ground. Ayan. So kompleto na yung ano natin, kompleto na yung mga components natin. Yung design natin, kompleto na. So merong resistor, merong LED, merong ground. Okay? So ang kulang na lang dito is yung firmware, no, yung software para i-run itong project natin. So gaya ng sabi ko kanina, you can change the value of this resistor by just right clicking on it and then edit properties. Then you can change the value. If you have a 330 ohms resistor, then you can edit that. And okay. And so it's already 330 ohms resistor. Okay. Then let's save this. Huwag kalimutan i-save kasi for example, medyo mahaba na yung ating or marami na tayong component na inilagay, no? Baka mamaya biglang nag-off yung yung Proteus natin, no? Masasayang lahat ng ating mga pinaghirapan. Okay? So, now let's open Arduino para gawan ng program itong Arduino natin. Let's open Arduino. Ayan. Dito natin siya gagawan ng firmware sa Arduino. Okay, Arduino. So, ituturo ko muna sa inyo dito kung paano kukunin yung firmware dito, no? Kasi yung program ng Arduino, hindi siya agad-agad yung magagamit natin doon. So, kailangan natin ng hex file. Kumbaga, yung program na converted na into hex. Kasi yun ang binabasa ng microcontroller. Okay? Yun yung binabasa niya. So, ngayon, let's create a new file. Yan. So, close na natin to. Tayo, bagos. From scratch. So, void setup, dito natin specify ano yung magiging function ng pin. So, ang ginamit nating pin ay okay. Lakyan natin. Ayan. Ang ginamit natin na pin ay pin number 2 ng Arduino. Okay? Pin number 2. So, kung pin number 2 yan, pagdating sa Arduino ngayon, pin mode. Okay? Ito yung pag-select ng mode ng pin. Na? Pin mode. Okay? Pin number 2. Ano siya? Input or output. Okay? Let's say output. Kasi LED ang nakabit doon, di ba? Output. Sorry. Yan, output. Ibig sabihin, yung mode ng pin number 2 ng Arduino mo is output. Ibig sabihin, ang function niya output na. Pag ginawa mo itong input, then, ang maging function niya is input. Okay? Hindi siya maglalabas ng 5 volts na voltage doon. Okay? So, ginawa natin siyang output para makapaglabas tayo doon ng 5 volts na signal. So, yun yung pag-declare. So, ito yung proper na pag-declare. Pin, and then uppercase M, mode, 2, and then yung output natin, uppercase lahat. Take note that this is a Java program. Then, it is case sensitive. Okay, so we have to be aware of the syntax. And then, gagamit natin kasi digital pin yun. Okay, check natin ha. Nasa digital pin tayo. Ito, digital pin ang tawag dito. Digital IOs. Ito yung analog IOs natin. So, we have 1, 2, 3, 4, 5, 6. 6 digital IO. Okay, dito naman sa part na to, hindi na nilagyan ng mga pin. Sa actual, ito yung ground, no? Positive 5 volts, positive 3 volts, no? Parang dalawa yata ang ground dito. Dalawa yung ground. Then, positive 5 volts at saka 3.5 volts dito nakalagay sa part na to. Okay? So, nasa digital tayo. Kaya pagdating sa Arduino ngayon, gagawin natin is digital, right? Ibig sabihin yan ay maglabas ng 5 volts. Saan? Sa pin number 2. Anong ilalabas? High. Ibig sabihin, pag high, 5 volts. Okay? 5 volts yan. Then, lagyan natin siya ng delay. Delay. So, ilan yung delay? Let's say, for example, 1,000. So, 1,000, that is in milliseconds. So, if that is in milliseconds, it is 1 second. Okay? So, then, para maging blinking siya, gusto natin magbi-blink yung LED. Ha? So, digital write ulit. Okay? Then, 2. Pin number 2 ulit. Piliin natin. Ano ilalabas natin? Low. Ibig sabihin, 0 volt. Okay? So, then, another delay. 1,000. Okay, magbi-blink siya. So, itong void loop natin, it is automatically naglo-loop itong program to. Ito yung nagra-run na program natin. Okay? So, digital write to high, delayed 1,000 milliseconds. Digital write, ito iilaw siya. No? Iilaw ng 1,000 milliseconds. Then, after ng 1,000 milliseconds, maglo-low na siya. Ibig sabihin, mamamatay yung ilaw. And then, that is in 1,000 milliseconds rin. After that, babalik ulit siya dito sa taas. Iilaw ulit, mamamatay. Iilaw, mamamatay. Okay? So, yun yung concept niya. No? Kasi naka-loop ito. Naka-looping dito. Na? Kaya, dire-diretso ang pagtakbo ng program na to. Paikot-ikot lang. Okay? So, ang una mong gagawin para makuha mo yung hex file, sabi ko na hex file, di ba? Para makuha natin yung hex file, punta ka sa file, and then preferences. Then sa preferences natin, i-check natin itong compilation. Okay? So, show verbose output during compilation. So, click natin yung compilation para magkaroon tayo ng path papunta doon sa hex file para mapuntahan natin yung hex file kung saan siya nakalagay. Okay? So, kailangan naka-check yung compilation and then okay mo lang siya. Click natin yung maliit na folder na yon. Ito sa program file, dito. Click natin tong folder na to. Click, and then punta ng desktop. Then hanapin natin yung sample1.ino.hex. Ayan. Then, open. Ayan. So, ngayon, nasa ano na siya, no? Nasa Arduino na natin siya. Okay natin. Ayan na. Save natin to. Okay? So, ngayon, ready din tayong i-run yung ating program sa Arduino. Click lang natin itong play sa baba, itong play button to run the program. Run. Ayan. Ayan, no? Nakikita natin ngayon, nagbi-blink na siya. Okay? Ayan, yan yung 1,000 milliseconds, no? Pero kapag nasa actual yan, medyo mabilis yan, no? Kasi 1 second yan. Okay? So, ayan. So, ayan, that is our first example, na? So, if you have question, you can comment below, no? Dun sa may comment section para masagot natin yung tanong. Okay? So, I hope na may natutunan kayo ngayon sa tutorial na to. Then, thank you very much for watching this tutorial. Then, see you in the next tutorial.